Hi everyone. In this video we are going to cover Docker Compose tutorial for beginners, and it's the ultimate guide to multi-container applications in 2025. So are you really tired of managing multiple containers with endless Docker and commands? So in this beginner friendly Docker Compose tutorial, I will show you how to spin up full multi-container applications in just one step. So by the end of this video, you will go from zero to confidently running linked services like APIs, databases and microservices, all with Docker Compose in 2025. So in this hands-on tutorial, we are going to use latest technologies to create our microservices, for example, Java 21 and Spring Boot 3. And with this, we are going to create multiple microservices, and we are going to manage all these microservices with the help of Docker Compose. So in this hands-on tutorial, you will learn exactly how to use Docker Compose to build, configure and run multi-container applications the modern way. So it will give you the solid foundation to containerize and orchestrate your environment with ease. So let us dive in. As you all know that in real practice we are dealing with multiple microservices, and while creating and different microservices and managing all those, we need to consider and take care of various aspects like we have networks, environment variables, port mapping, volumes, and there is a dependency. As for example, our order microservice depends on the customer microservice. So we need to maintain the order and the sequence in which each and every microservice is going to be executed and run. So all these things are we need to consider while we are dealing with multiple microservices, multiple containers, and like we need to maintain the sequence and order in which our services are getting called as well. Apart from that, each service has its own database, so we need to take care of database part as well. So each microservice has its own Docker file. So Docker file in which we are going to mention everything related to the container definition, how the container are going to be created. So our Docker engine will take help of this Docker file and will create the container for each microservice. Now, while creating the container, if the service is using the database like MySQL or PostgreSQL, we need to create a container for that database, and we need to create a container for our application as well. So looking at all these things, as our application grows, the things will become more and more complicated and unmanageable, because we need to create the individual Docker images and run the individual containers, and we need to maintain, remember the order on the sequence in which we are running all these, and moreover, like we need to keep in mind what is the dependency for each services. So as the time grows, it will become more and more complex and tedious to or hard to handle all these things. So what is the solution for this? So is there any one place solution wherein we can keep all these things? Like we have network dependency, volumes and port mapping and order and database. All these things we need to manage at one place. And what is that one place? That is the one place which is a Docker Compose file, YAML file, wherein we are going to mention everything related to that microservice. So it's a Docker Compose. It is not specific to a particular microservice. It is out of all the microservices. It is the one file wherein we are going to mention everything related all the microservices, like how one service, if there is a for a particular service, we are going to mention the service, its build, context or port mapping, or if it has any dependency, environment and volumes, and all these things we are going to mention in this Docker Compose YAML. And as many services we have, those many definitions of those microservices we are going to mention into this Docker Compose.yml file. Now let us see what is the Docker Compose. So Docker Compose is a tool for defining and running multi-container Docker applications. Like as we are going to create multiple microservices, so it will help us to define and run our multi-containers with ease. Like we are going to define the definition at one place and it will create, run the containers for all the Docker applications. And it gives us a control of our entire application stack, like making it easy to manage services, networks, and volumes in a single YAML configuration file. So that means we can define all of our application stack in a single YAML configuration file, and with the help of some Docker command, Docker Compose command, we can spin up all the containers for all our microservices. Let us see what are the benefits of using the Docker Compose. First is a simplified multi-container management. What does it mean? That the Docker Compose allows us to define and manage multi-container applications in a single YAML file. So this simplifies the complex task of orchestrating and coordinating various services. So making it easier to manage and replicate our application environment. It will bring up the entire environment with a single command. Next is efficient collaboration. Like Docker Compose configuration files are easy to share, so we can facilitate the collaboration among developers, operation teams, and other stakeholders. So with this, we can maintain the workflows, achieve faster issue resolution, and overall efficiency. Next is a centralized configuration. So we can manage ports, volumes, and environment variables and dependencies in one place. Next is a rapid application development. Like Docker Compose will cache the configuration, which will get used to create a container. And when we restart a service that has not changed, the Docker Compose reuse the existing containers. Like reusing the container means that we can make changes to our environment very quickly. So no need to scatter the Docker run commands or the shell script. And it will help us to rapidly develop our application. Next is a portability across environments. Like Docker Compose supports variables in the compose file. So we can use this variable to customize our composition for different environments or different users. And there is a last one, which is the extensive community and support. Like in this, Docker Compose has a vibrant and active community, which means that abundant resources, tutorial, and support. This community-driven ecosystem contributes to the continuous improvement of Docker Compose and helps users troubleshoot issue effectively. So these are some notable benefits of using Docker Compose. Now let us see what is the structure of our Docker Compose and what we are going to implement. So at the root level, we have the Docker Compose as a parent folder in which we are going to define multiple microservices. Like we have customer service, order microservice, and rating microservice. And order service depends on the customer service, because our order service controller endpoint is going to give a call to the customer service endpoint, REST controller endpoint. In that sense, order service has a dependency on a customer service, and we are going to mention that dependency into the Docker Compose file, and I will show you how we can do that. And rating service is an independent service which has only a single endpoint which will show some message. But customer service and order service is going to use the H2 database inside that, and order service is giving a call to the customer service. And for H2 database, we do not need to pull or download the image from the Docker Hub, because H2 database is a file-based in-memory database, and it is running inside the Java process. So we do not need to explicitly pull or download the image for the H2 database from the Docker Hub. Now for each microservices, we are going to create application.yml file, and we are going to create a Docker file. So what is the application.yml? Application.yml file wherein we are going to define application specific properties inside that, and like what is the server port and what is the application name, and if there is a database it is using, we need to mention the database properties inside that. And in case of Docker file, we are going to mention in that like container definition, like how Docker engine is going to create the Docker container out of this Docker file. So Docker engine will take help of this Docker file to create the Docker container. So in this Docker file, we are going to mention container definition, and our Docker compose is going to refer this Docker file to create the Docker images. Now this is the application stack, like for each microservice we are going to use application.yml file and Docker file. And finally, which is the most important thing which we are going to cover, is we are going to create one docker-compose.yml file. And in this docker-compose.yml file, we are going to mention everything related to all our applications, like we have customer microservice, order and rating. So all these microservices we are going to mention inside the docker-compose.yml file, and we are going to mention the network and the depends on environments, volumes and port mapping. Everything we are going to cover in this docker-compose.yml file with some real practical example. Now the question comes in your mind, like we have Docker file for each microservice, whereas we are going to also mention inside the docker-compose.yml file as well. So the point here is that like Docker file is specific to that particular microservice, okay, and anyhow the Docker compose is going to refer that Docker file. So Docker file is needed because even though we are going to define the container definition inside the Docker compose, we need the Docker file because Docker compose will use that. And in case if we are dealing with multiple microservices, like we have 20 or 30 microservices, and if we want to test a particular microservice, then running the Docker compose and spinning up all the containers, 20, 30 containers for each microservice is not a feasible approach. At that time, we can simply create the particular service Docker image using the Docker build command and run that particular microservice using the Docker run command. And we can test the particular use case and we can provide the fix and we can build it again. And after that, we can run our Docker compose. So that we can spin up all the services which are running in a healthy path scenario. So that is the case, like we need a Docker file per service for various purposes. So we need to create that as well. But the main point is that we are going to use Docker compose, which is very important, in which we are going to mention all the details of all the microservices with the, including the port mapping and the network, volumes and depends environment, everything we are going to include inside the Docker compose. So I will request you all, so please do not forget to like, subscribe and share. I need your support to grow my channel, so please do not forget to like, subscribe and share. Now let us first create one parent folder wherein we are going to keep all our Now let us create one parent folder wherein we are going to keep all our microservices. We can give a name like docker-compose. This is the parent folder wherein we are going to create all our microservices. We can copy this path. Now let us open the Spring Tool suite first from here, and we can paste the path for the folder which we have just created, and we can click on launch button. Now this is our Spring Tool suite editor. Let me open the so we can go to the preferences. I am just going to increase the font so that it will be visible. Here inside that we can go to edit and here we can use 12 instead of 10, and we can apply and close. Now this is the editor. Now first thing we can do, like we can create our Spring customer service. For that we can click on this third option, which is create new Spring starter project. Here we can give our service name, which is customer-service. We can choose Maven as a build type, packaging as a jar, and here we can select the Java version. We are going to use Java 21, so we can select that. Here we can use a group as a com.customer, and here we can say it's a customer project, and here we can use customer as a package. That's it. We can click on next button, and here we are going to mention what all packages dependencies we are going to use. First is a Spring Web. Next we are going to use actuator. Next we are going to use Spring Data JPA. Next we are going to use H2 database, and next we are going to use Lombac. And we can click on next button and finish button. Now we can see our customer service project is created successfully with all the dependencies that we have added. Now let me show you that dependency once. So it is still importing the project. Okay, fine. Now here you can see this is the dependency. Let me close this. Okay, fine, it seems good. Now we can see this is the dependency section wherein we have added all the dependency. It is actuator, Spring Data, Spring Web, and H2 database, and Lombac. So this much dependency is enough. Now let us resolve this error, which is it is showing red. So let us replace this HTTP with HTTPS, and we can save the changes. Now first thing we can do, like let us create the packages, what all packages we are going to use. So we can right click on this com.customer, and we can select the package. Here we can use entity first package. Next we are going to create our repository package. Next we are going to create our service package, and next we are going to create our controller package, and we can click on finish button. Now let us create one application.yml. Let me delete this. We can either use application.yml or application.properties, either will do fine. So let us create one application.yml file. And inside that we can mention what all things we are going to use. First is a server.port. We are going to use what port we need to mention here. Let me put some port. Let's say it's 8085. Next thing we are going to use spring.application.name. This is our application name, and here we need to mention what is the service name. It's a customer-service. Next thing we are going to mention the data source. Like this is we need to mention the data source part. For data source we can use mention the URL. So we are going to use H2 database, which is a file based in-memory database. So we can mention JDBC. For URL we can mention JDBC colon H2 colon mem, and here we can use the database name. Let's say cust-db. So this is the database name we are going to use. Let me add the driver class name, and for the driver class name we can use org.h2.driver. For each database there is a specific driver. For H2 this is the driver class name. Next we can add username, and let's say here we can add some username, like this is for customer, so we can add cust as a user, and we can add password. cust@123. This is the password we are going to use. Next we are going to use the h2, like for h2 console we are going to use, so we can add this, and for this console we can say it's enabled as a true, and after that we can mention the path. For the path we can say path, this is the h2 console. So if we want to access the database through browser, we can use this h2 console, we need to use that. Next thing, like we can use GPA Hibernate properties, GPA Hibernate, and we can use TDL auto as an update. Next we can use show-SQL as a true, because we want to show all the executed queries into the console, so that's why we can make it enabled as a true, show SQL as a true. Next and final thing, we can use database platform we need to add, and for this we can use or.hibernate.dialect. This is the dialect part, and for each database there is a specific dialect we need to use, and this is the dialect for h2 database we need to add. So this much is enough as a part of YAML file, so we can resolve this indentation related error. So for that we can copy it, and let me open the notepad++, and here we can replace every occurrences of tab with the 2 spaces, so that we can click on replace, and it has replaced all the 27 occurrences. Now let me copy this and let me put it again, so that instead of resolving every individual line, we can resolve this in one go. Fine, we have saved it. Next thing, let us create our customer entity first. So here is our entity package. Let me create the customer entity, and here we can add all the necessary import for this customer, like we are going to use all our constructors, node constructors. Next we are going to use builder. Next we are going to use entity, which is an important package for this customer, and for this we are going to use @data as well for this class. So we have added all the required necessary imports for this customer class, and this is the entity, which is an important because this is the entity class. Now let us add what all properties we are going to use inside this one. Now first thing, we can use private long id, which is a primary key, we can say. Next we can add private string name for customer. Next we can add private string email, and next we can add private string location or address, whatever, and we can save it. Now we have this data package, so we don't need to add the getter setters, but sometimes but we need to add the Lombak jar dependency inside this. So let me add getter setters explicitly, so that it should not show any getter setter errors. So let me add it for now. Now next thing what we can do, like we can add the id annotation at here. Next we need to mention what is the generation, like we can mention generated value, and what is the generated value. For that we can mention what is the strategy. For the strategy we can use generation type. So for generation type dot, we can use auto. This is the generated value, this is the strategy, and for generation type dot auto, and let me add all the imports, necessary import for this one. So this is the strategy. Here annotation is missing, so that's why it is not showing. Let me add import. Fine. So we are done with our entity, customer entity. Now let us create our customer repository, and here it's an interface. We can name it like customer repository, and we can add stereotype as an repository because this is going to be a repository, and this class, this interface should extend either JPA repository or CRUD repository. So we can choose JPA repository, and here we can mention our entity which is customer in our case, and here data type of the ID which is a long, and we can add all the necessary imports and we can save it. With this we are done with our customer repository. Now let us create customer service. First we can create a customer service interface, and inside that we can add all the necessary methods which we are going to implement. Now let me add first like get all customers, which will return all the customers which are there inside the database, or we can say fetch all customers. Next we are going to create customers. So for that we are going to add create a method like create customer, and here we can pass the input customer which need to be created. Next thing, we can create one get customer by ID method. For that we can use this optional, and here it is the customer, or we can use like this is the customer, and or let us use the optional which is good optional. This is the customer, and here we can use get customer by ID, and here we can pass the input ID which is a long ID. Now we can add all the necessary import for all these. Seems good. Now these three methods are enough for us. This is for returning all the customers, this is for creating a new customer, and this is like fetching or getting the customer by the ID which we are going to pass. Now next thing, let us create one implementer class with name like customer service IMPL, so that we can provide all the implementation for the methods which we have mentioned inside the interface. So let me add a stereotype class as a service, and here this class should implement our customer service, and we can add all the necessary imports, and we need to provide the default implementation for all these methods. Now let me inject our repository so that we can call the respective methods which are there inside the repository. This is the customer repository which we are going to use, and we can use this. Now we can add import for this one. Now let us create one public constructor, and for this customer service IMPL, and inside that we can add this repository and we can use this dot customer repository as a customer repository we can pass. Here we have initialized our customer repository inside a constructor. Now we can use this customer repository to call the respective methods, like we can use return dot find all method, which will return all the customers which are there. Similar way we can use save method, which is we can call the save method on this repository, and this is our new customer input which we need to save into the database. Now here we can call the respective method, like it should return the optional, so for that we can call like return, and we can call the respective method which is available on the customer service, and the name of the method find by ID, and we can pass this long ID so that it will return the respective customer object for that ID. So with this we are done with our customer method customer service implementer class. Now let us create our controller, which is the last thing for this customer service. This is the customer controller we are going to create. Now we need to add the respective annotation, like it is the REST controller, and inside that we are going to add, first we need to inject or annotate our service, which is a customer service. We can add import for this. Next thing, we can add one gate mapping, and for this we can use /customers, and here we can use like it's a return type which is a response entity. Inside that we are going to use return the list of customers, so we can use this, and here we can give the appropriate method name like get all customers we are going to use, and here we can remove this part which is not needed because it's a get method. Now here we are going to return the actual return the response. For that we can call the method which is available on this customer service dot, we can say fetch all customers. So here is a spelling mistake, but it should be fetch all customers we are going to use. So let me correct this spelling mistake, it should be fetch all customers, and we can save. Similar way we need to correct this method at here as well inside service implementer class, and finally we can correct the method at here. Fine, we can add all the necessary import like list and all, seems good. Now this is the get customer method we have covered. Similar way we are going to create one method which will allow us to create the customer into the database. So we can use post mapping, and here actually after adding a new customer it should return an individual customer, not the list of customers, and here we can use method name like create customer or add customer. Inside that we are going to use the request body because we want to insert the customer into the database, so we need to use the request body, and this is the customer, and we can say it's a new customer, and we can call the respective method which is available on this service customer service, which is a create customer, and this is the new customer we are passing. Now let me add all the imports for this, and we can save it. This is for creating a new customer inside H2 database based on what input customer we are passing. Next thing, like we need to create one method for getting our customer based on customer ID. For that we can copy this get method first, and let me add one more method. Like here we can say this is the customers. After that we need to add what ID we are going to pass inside bracket. Next we can change the return type because this is the optional customer, it is going to return, so we can use that optional customer inside the response entity. And the method name should be get customer by ID because this is the appropriate name. Next thing, we are going to pass the path variable, which is an ID, and here we can say it's a long ID, and here we can call the respective method like get customer by ID, which is available on this customer service. Now we need to add import for this optional. That's it. With this we are done with our all the methods which are there inside the controller. Now let us build it and test it at local first, and after that we can see. Now let me build it. So this is our build tab. Now let me build it by using run as maven install. We can say it's a build success. Now let us run it by using run as Spring Boot app. Now we can see our service has started successfully on port 8085. Now let me open the Postman and we can test the result. So this is our Postman. Now here we can test our results. We can open one new tab, and here let me use our URL, which is localhost 8085, which is a port for customers, and we can select the body. This is the get HTTP method. We can select the body, like we can select the body, and here we need to select, after that we need to select this is the raw, and after that we can select the JSON part. Okay, fine. Now let us hit this button so that it will show. Now it is showing empty data because we have not added any data as of now. So let us see what is the data we need to add. We need to open a customer entity which is there. Okay, so you can see by mistake we have added the customer controller inside the customer package, which should not be added there. So let me just stop this and let me put the customer class inside the appropriate package. Even if we add it in this level, that is fine, but which is not good as far as our best practice is concerned. Let me copy this and let me add it here. Let me delete this snippet.java, which is not necessary, and let me delete it from here as well. Okay, fine. Now it seems good. Now we have made the changes, so we need to build it again. So let me build it again with using the maven install. So we have not made any much changes. We have just copied put our controller class inside the controller package. That's it. Now this is our build success. Let me rerun it using Spring Boot. We can say it has started successfully on port 8085. Now we can test it. Now this is our 8085 customers. We have selected raw and JSON. Now we can hit for this get method for returning all the customers. Now it is showing the empty array because we have not added any customer inside the database as of now. So to add the customers, let us open the customer entity and see what all fields we are going to use. It's a name, email and location. Now let us add one record with this. Like first we need to pass the name. Let's say here we can add like Shiv. Next we can add email for Shiv, which is, let us say, shiv@gmail.com. This is the Gmail or any email you can add. And next thing we can add location for this customer, and we can say it is in Pune. It's in Pune. So this is the customer details we want to save into the database. For that we can use the appropriate post method, post HTTP method, and this is the endpoint. We are using the same. Let me cross check it. So this is the customer controller and we are using the same endpoint. Based on the HTTP method, it will differ. Now we can click on send button. Now it has created one record successfully. That means our create customer is working fine. Let me add one more record with name, like let us say it's a Peter, and we can add respective email ID of the Peter, and we can say it's in Paris. Now let me add this record. We have two records added successfully. Now we can cross check by using the get method, and here you can see it has shown. Now if I want to get the particular object for this second ID, we can simply hit this and it will show the second ID, give us the second ID. Okay, so all our APIs which are there inside the controller are working fine. This is the last one. This is for create customer and this is for fetching all the customers, and we have tested all this code on the with the help of Postman. Now we have successfully created our customer service. Now let us create our order service, and order service depends on this customer service. So let us create this order service. So for that we can right click on this, and here we can use Spring Starter project, and here we can give our service name, which is order service. We can choose build type, and group we can use com.order, and rest of the things we can keep as is. And this is the order service and this is the package name. Now let me click on next button, and here we can add what all dependencies we are going to use. Like we can add actuator dependency. Next we are going to add Spring Web. Next we are going to add data JPA, Spring data JPA. There is the H2 database dependency, and we have Lombac. And finally we can add, because our order service is going to give a call to customer service, so for that reason we need to add OpenFrame it here. This is the Spring Cloud dependency we need to add, and I think this much is enough as a part of dependency. Fine. Now let us click on next button, and we can click on finish button. Now here we have our order service, and let us cross check the dependency ones. Like we have all these dependencies which we have added now. Fine. And this is the important one, OpenFrame, because this is the best for synchronous communication, and our order service is going to call the customer service. So in order to achieve that communication, we are going to use this. Now let us resolve this error. Red it is showing. Let us replace HTTP with HTTPS. Here the best thing, like we are going to use this Spring tool, Spring version 3.5, and Java version we are going to use, which is 21. So these are the latest technologies we are going to use for all the microservices. Now let me save it. Next thing, this is our order service application. Now we need to enable the Fin client so that we can achieve our communication. Next thing, let us create the respective packages which we are going to use. So let me create the package as an entity first. Next, I can create a repository package. Next, I can create service package. And finally, we can create our controller package. So we need to create one more package because our order service is going to call the customer service. So we need to create a customer client inside the order service. So we can create one client package. That's it. Now let us create our entity first. Like we can create our entity inside this entity package with name order. Let me add orders as an entity and we can finish. And here we can add all the respective annotations like all our constructors, no constructors, or we can copy the rest of the, like we have all this much annotations we can copy and add to our order entity. Next we can add our data annotation like this one, and we can add import for this one. Now let us define what all fields we are going to use. Like we are going to use long ID first. Next we are going to use string name, order name, and next we are going to use the double as a price we are going to use. Next we are going to use our integer field which is a quantity, and finally we are going to use like private long customer ID because we are going to give a call to customer service from the order service. So with this field we are going to get the details of the customer, so we can save it. Now let us create all the getter setters using this source and getter and setters. We can select all and generate. Now we can save it. With this we have created our entity class successfully. So let us create one repository interface with name order repository, and here we can add a stereotype as a repository, and here this interface order repository should extend either JPA repository or CRUD repository. So we can add this, and here we can use entity class which is orders. And what is the data type of the long ID field, which is a long. Let us add all the imports and we can save it. With this we are done with our repository, order repository. Now let us create our service interface with name like order service. Inside that we can add all the fields which are necessary, all the methods which we want to call. Like let me retrieve all the orders by using this get all orders method. Next we are going to create orders. So we can say create orders, and here we need to pass new order which is of type orders. So these are the two important methods which we have added inside the interface, and we can add all the imports which are there. Now here it is not the inbuilt class order, rather it should return orders which we have created, and we can save. This is the service interface. Now let us create one class which will implement all the methods which are there inside this service, and we can name it like it's an order service. impl. Now let us create the implementer class, and we can annotate it with service stereotype, and it should implements our order service interface, and we can add all the imports. Now we can provide the default implementation for all the methods which are there inside this order service. Now let us auto-wire our repository part, and we can use this private order repository and here we can use this, like we can create one constructor order service impl, and here we can add this, we can initialize this repository part. We can use this dot order repository, and this is the order repository we are going to initialize it with, and we can save it. Now let us add the respective methods on this to provide the implementation part. For get all orders, we can call the method which is available on this repository find all, which will return all the orders. Similar way we are going to create the order using, like we can call save method, on which we are going to create a new order, and we can save this. Now we have successfully created order service implementer class with all the necessary methods. Now let us create our controller part. So here we can give our controller name, which is a order controller. Now here we can add a race controller, and here we can auto-wire the service which we are going to use to call the respective methods of the order service. Now here we can add one get mapping which will return all the orders which are there inside the database. So we can use the endpoint like orders, and here it should return like a response entity. Inside that we are going to use list of orders, and we can say get all orders, and here we can say dot OK, and here we can call order service dot get all orders, and we can add imports for all these, and we can save it. Now this is for getting all the orders. Now we need to add one more method which will get the customer based on the like we can add one more method like instead of get the customer we can create the order, and while creating the order we are going to give a call to the customer service. So let us add that. We can use like we can copy this get mapping, and here to create the order we are going to use post mapping, and for this like we can use place order as an endpoint, or we can say create order, post mapping, and here we can see method name as a create order, and it should return only the order, individual order, which has created into the database. And here we can call the respective method which is there for creating order, and here we need to add the request body because we are going to create a new order. So for this we can use our orders, and this is the new order which we are going to save into the database, and we can add respective annotation for this one. Now with this it will save, but before we save we are going to give a call to our customer service. So how we can give a call? For this, first of all we need to create one customer client, okay, because inside the order service we need to create one customer client, and we have created this client package. Let us create a customer client. Which is an interface, so we can say customer client. We can change it later on, instead of class we can say it's an interface. Now this is the customer client, and here we need to annotate it using the FAN client because we are going to use that as a FAN client. And here we need to mention what all things we are going to use, like this is the name, and what is the name of the service, which is a customer service we are going to give a call to. And next we are going to add URL, which is we can say HTTP localhost, and here we can add 8085. This is our port name of the customer service, and we can save it. Now let us add one get mapping it here. Get mapping, and inside that we can mention our endpoint, which is customer/id, and here we can give our signature of the method like get customer by id, and inside that we can pass the path variable which is of type id, and we can say it's a long id, and we can add. So this is the customer. So for this, like we need to create a similar object of the customer which is there inside the customer class. So we can copy this class and we can add this class inside. Now this is the, so we can create one more model field, model package at order level, which is a dot model, and here we can add, paste that customer class. This customer class is same as what we have created for the entity inside the customer service. Now let us remove this because this is just simple Pojo, Java Pojo class, and it is not going to treat as a entity. So we have just added similar fields, but it's not an entity, it is just a simple Pojo class. Now we can use this, we can add the import for this customer which is there inside this model, and we can save it. Now we have successfully created our customer client. Now we need to create one service in which we can use this customer client. So let us create one customer service. We can annotate it with using service level annotation, and inside that we can add, this is the auto add, and inside that we can use private customer client, and we can use this customer client field. And we can use this public method customer get customer, and here we can use this long id. And here we can call the customer client method which is available on the customer client dot get customer by id, which is a long field, and we can add import for all this. So with this we are done with our customer service. Now we can make use of this customer service inside our controller. So let us go to our controller, order controller, and here we can copy this part, and here instead of order we can say it's a customer service. And we need to add import for this customer service which is available inside the order service we have just created. Now with this customer service, now with this we can add one more thing, like this is our customer service. Now we need to get the customer based on the ID first. So let us check that. So here we are creating the order. First what we can do, we can get the customer object on, and for that we can call the respective method which is available on the customer service, and we can call get customer, and here we can pass the ID of the customer, and we can add like get customer ID. So this is the ID we can pass. So based on the customer ID we are going to extract the customer object. Here we can add the import for this model customer, and here we can check if customer object is not equal to null, then we are going to return this, or else we are going to return null. So here actually this is the inter-service communication using Fein client. We are going to achieve this, like order service giving call to customer service. Okay, so based on what customer ID we are passing, on basis of that it will return the customer, and we are checking whether it is not null. In that case we are calling the creating the order service, creating the order, and we are returning that. Now if you want to specify it in more way, we have to, instead of returning null, we can say we can create one more customer object, customer, and we can say customer response, and here we can assign the customer response to this, and finally we can return like whatever customer response we have received, we can add. Create order, sorry, it should be orders, not customers, it should be orders. That's it, this is the orders, and we can say it's order response. So here it is communicate, this is the call, like we are getting the customer based on the ID from the order service, and we are checking if the customer object is not null. In that case we are creating the order, and this is the order response, here we are returning. That's it. Now we can save it. So this is for order controller, we are done with. Now let us test this and check how it goes. Like we need to test it, for that we can build it using run as maven install. So there is one test failure, so let us comment out the test for the time being. I can select all and we can comment out. Fine. Now let us rebuild it again. Now it's a build success. Now let us run it. Now we have not created our YAML file, so let us create one YAML file. Let me copy the YAML file which is there for application customer. So let us add that inside. Let me remove this application.properties because we are going to use the YAML file, and we can paste the YAML file from the customer into the order. Now here we can make the respective changes, like we need to change the port. Let me take 8084 for order service, and here we can say the database, we can give order.db, and we can keep as is username or password, or we can change, that is up to us. Now let me save it. So we have successfully created order service. Now let us build it again because we have added the YAML file. Fine, it's a build success. Now let us run it using Spring Boot app. Okay, so let us check our entity class which is there inside our order entity, orders entity. Okay, so here basically we need to add how we are going to create the ID. So let me copy that part from the customer and we can add it to the order entity, and we can save it. Now let me once again, so first we need to run our customer service because it's a dependent service, so we need to call this first, run this. Next we can build our order service and run it. We can run it using run as order service. Now here we can check like our order service is running successfully on port 8084, and here is our customer service which is running on port 8085. Both the services are running fine, and we can check this from here. Now let us hit the order related APIs and check how it goes. Like first we can check for orders, like this is the 8084 orders. We can select the body, and here is a raw, and here we can select the JSON, and we can click on send. Now it is showing the empty array because we have not added any order as of now. So let us check whether it is showing any customer inside our customer service. It is not showing any customer, sorry, it should be customers. It is showing empty array, so let me add one record using post. We have added one record. Similar way we can add other record, like we can add, let's say it's a Kavita, and we can add the respective email for Kavita, and here we can say she is from Mumbai, and we can add. Now we have successfully added two records. Now let me hit the get method, get API, and check how it goes. Now it is showing two records which we have just added. Now we have customer service with some data. Now let us add our order service, hit the order service endpoint. Why we have added second time into the customer? Because we stopped the customer service, and as we are going to use H2 database, which is a file based in memory database, so every time we restart our customer service we will lose our data. So for that we are calling this endpoint again to just to populate the data. Now let us test our orders. Here it is showing empty. Now let me give some order name. Let's say is for HP product. Next we can add some price, which is a double, let's say 45,000.50. Next let me add quantity. Let's say it's a 5 quantity, which is an integer field. And finally we can add customer ID. For customer ID we can use second as a customer ID. Now if we want to check the second customer ID by calling the customer endpoint, it will show the customer ID, a customer which is a Kavita. Now here we can use our post endpoint to add this entry into the order database. Now it is giving. So for placing the order we have some other endpoint. So let us open the controller and check. So here we have create order, so we need to use that. That's why it is not adding. Seems good. We can see it has added successfully for this customer ID second. That means our inter-service communication between the order service and customer service successfully established, and finally we have created the order. Like let me show you, like this is where we are going to achieve the inter-service communication from order service to customer service, and here we are checking like if it is a successful communication done from the order service to customer service, and if we got the customer object, then only we are going to create the order. That's it. Now we are done with our order service as well, and we have tested both the results for both the endpoints for the order service. Now we have successfully created customer service, and next we have created order service which is dependent on the customer service. Now let us create one independent service like a rating service with some simple endpoints. So we are not going to use H2 database. It will simply return some message like the rate, how is the rating of the particular product. So let us create one more microservice using this Spring Starter project. And here we can say it's a rating hyphen service, and here we can use package as a group as a rating. It's a rating project, and similar this is package which is com.rating. Now let us add the dependencies. We are simply going to use Spring Web, and this much is enough. We are not going to use anything else. Now let me add one controller. So let me create one controller package. And inside that we can create one controller with name. It's a rating controller. And here we can annotate using the race controller. And simply we can add one get mapping, and here we can say it's a slash rating, and it is going to return some string, and here we can give some string name like it's a get rating method. and we are not going to pass anything. It is just a dummy endpoint which will return some string message like product has overall rating 4, which is best among the ratings. Okay, so this is the message we want to return, and here we can add all the respective import for these things. Now here we need to complete the statement and we can save it. Now we have completed this rating service. Why we have taken this rating service? Because we want to explain the Docker Compose in a proper way. Now we have two services in which order service is dependent on the customer service, and this is another service. Because we want to mention how we can add a dependent service inside this Docker Compose. So these two services are important, and this is one of the independent service we are taking as an example. Now let us build this and check the endpoint. Now here we need to add our YAML file, because let me remove this, delete this, and we can add with the YAML. We can copy this and we can add it here. Now we are not going to use the database part, so we can remove all this stuff which is not needed, and we can simply give this change the port number. We can keep 8086, and here we can say application name is a rating service. That's it. Now let us rebuild it using maven install. Fine. Now let us run it again. Now we can see our service rating service is started successfully on port 8086. Now let us hit to call the get mapping on this, like we are going to use port number 8086, and this is the ratings. We can choose body, raw, and here we can choose the JSON, and we can send it. Now let us check what is the endpoint we have given for this controller. It is a rating. Okay, so we can keep the same as a rating. S was there, so we have removed. Now it is showing this message successfully. That means our endpoint is working. This service is working. So far we have created three different microservices. First is the customer service, next is order service, and finally we have created our rating service. And we have tested all these using the Postman and verified the endpoint result. Now let us dockerize all these services. So when we say dockerize, what we are going to do, like we are going to create a Docker file for each microservice in which we are going to include the container definition. So container definition will tell the Docker engine how it should create the container, Docker container for each service. So we need to create a Docker file for each microservice in which we are going to define the container definition. Next, we are going to build our application to the Docker image. For that, we are going to use docker build command. And next, once our Docker image is created using the docker build, then we are going to run our image using docker run command. And finally, our application will run into the container. So each individual application will be run into an independent isolated container, and we can test our endpoints using the Postman again. Now this is our three different microservices. Now let us create one Docker file. While creating a Docker file for customer service, we can right click new, and here is a file. And Docker file do not have any extension, it's only Docker file, and we can create at the root level. Now we need to add what all things we are going to use. We are going to use like OpenJDK, so we can use it's OpenJDK 21. For that we can use from OpenJDK, and here we can use 21 JDK and Slim. Next we can set working directory. For that we can use work directory, and after that we can use our service name, which is a customer hyphen service. This is the directory we are going to use. Next we are going to declare build arguments, and we can use argument like jar file, and we are going to use the target hyphen slash star dot jar file, and finally we can add copy command, copy jar into image. For that we can use this copy command dollar, it's a jar file, and next to that we are going to mention our jar, which is customer hyphen service dot jar. Next to that we are going to expose our port, which is like expose. In for customer service we are using 8085, so we can use that. And finally we can use run the app, and for that we can use entry point, and here we can use Java as an executable. Next we can use hyphen jar command to create a jar, and after that what is our jar? It's a customer hyphen service dot jar file, and we can save it. Now what all things we have mentioned, let us recall. So first we are using the Java 21, so we have used appropriate version of Java OpenJDK. Next we have mentioned a working directory, and which is a customer hyphen service. Next we have included the build arguments jar file. It is pointing the target because inside target we have our jar file. Next we are going to copy the specified jar into the image. So for that this is the command, copy command, and we are going to expose the port, which is 8085, and finally this is the command to run our application, entry point java hyphen jar, and this is our actual jar. We can save it. So we are done with our creating a Docker file for customer service. Now next thing, now let us create the same Docker file for rest of the two services, so that we can create the images and run the containers in one go. We can copy this for order service as well. Now for order service, this is the Docker file. Now we can change the respective things inside it, like it should be Docker order service. Same, we need to copy it here, and it is it here. And what port we are using for order service? It is 8084. This is about order service we are done with. Now we can save it. Similar way we need to copy this Docker file into rating service, and for this we need to make the changes accordingly. Like this is the rating service, so we can copy this rating, add it respective places, and what is the port number of the rating service, which is 8087, and we can save it. Now where you can check the port, this is the port we are using, so same port you need to add inside Docker file for exposing, and we can save it. So we have successfully added 3 different Docker files for each services. Now let us build our application to the Docker image. Let us see how we can use that. So for that, first thing we need to do, like we need to first open our Docker desktop. We need to start this, and the next thing, like we need to use our Docker Hub. We need to log into. So this is the URL. Now here we can sign in. You can provide the password. Now we are inside the Docker Hub. Now we have successfully created this image. So far we have only successfully started our Docker desktop. We have not created any image or container as of now. So this is the Docker desktop, and next we have logged into our Docker Hub. These two are essential for creating the Docker image. Now next thing what we can do, like here, now you can observe like we are using the H2 database. That's and H2 database is a file based in-memory database. So for that reason we do not need to download or pull the H2 database image from the Docker Hub. We used to do for rest of the databases, like in case of MySQL or PostgreSQL, we need to pull the image or download the image from the Docker Hub and run into the container. So that is not the case in case of H2 database, because H2 database is running within the Java process. Now let us go to the folder, respective folder. From properties we can go and reach the respective folder of customer service, and we can open the command prompt. From here we can first build our Docker image using command docker. So first thing we need to make sure that we need to build everything, because after adding the Docker command, Docker file into the project, we need to build all these things. So this is for customer service. Now as we are building this, now in case of order service, one more thing we need to make sure that here for the local development we can use the local host, but if we want to communicate within the container, we need to give the appropriate service name, which is the customer-service instead of local host when it is a container to container communication. Now this is for order service. Now let us build it. We need to save that and let us build it using maven install. This is for order service. Now let us build the rating service as well. Now all the three services we have built successfully. Now we are not going to run from the STS, because we are going to build the images and run into the container. Now we have successfully created a Docker file for each microservice. Now let us see how we can build our application to images and run into the container. Now if we build each application into an individual image, like if we build each individual application and create an image for it, this is the command for creating the image, and this is for command to run our application. Now the problem is that as we are going to run individual application into the container, we need to create a shared network for that. After that we need to use that shared network to run our container. So this is for running the customer service with the shared network, and this is for order service, and this is for customer service. And there is one more change. We have made this change for a fan client, and after that we can test our services. Now this is a bit time consuming and it is a bit complex option we need to use to build the images and run our application into the container. So, and which is not a recommended approach as well. In running the individual containers, we need to maintain the order and sequence. We need to understand in which order and sequence we need to run all these things. Now the better approach is to create a Docker container. Now is to create a Docker compose file. So this is let me remove this file and let us create one Docker compose file. So this is our customer service. Now let me copy one YAML file from here. This is our application.yaml, and let us create one Docker compose file inside. This is our root folder, inside which we have three different microservices. Now let me copy this application.yaml. Now we can rename it to our Docker compose. docker hyper compose.yml. So this is the docker compose.yml. Now let me open it. Now we can see it has all the customer service related stuff. We can remove this, which is not needed for docker compose. Now what all things we are going to mention into the docker compose, let us see. So first thing, we need to mention the services. Inside that we are going to mention first is a customer service. Inside that we are going to add build. Inside that we are going to mention contest, and for that we are going to use the customer hyphen service as a contest. Next we are going to mention what is the container name, and for that we can use container hyphen name underscore name, and what is the container name, which is a customer hyphen service. This is the container name we are going to use. Next we are going to mention ports, and for this what is the port, like we are going to use 8085, which is the host port, and 8085, which is the container port for customer service. Next we are going to mention volumes. Volumes is like data persistent even after we close the container. For that we can mention customer hyphen data, and we can mention this is the data part for customer. Next we are going to use networks, and for this we can say this is the backend. So this is for customer. Similar way we can copy this and we can add one more for our order. So here we can make, let us check the indentation if it is correct, seems good. Now here we can make the respective changes for related to order, and we can copy this and we can add for contest. This is for container name, and here port number for order service is 8084 and 8084. This is the order data, that's it, and we can save it. Similar way we can copy this part and add for a rating service, and here we can mention like this is for a rating, and we can copy the rating and add, make the respective changes for the rating, like this is for rating container name, and here port number we are going to use 8086 for rating, and here we can use respective changes for volumes and we can save it. Now we have added 3 different microservices. Now one more thing we need to mention, order service depends on the customer service, so we need to add depends on. And inside that we can mention what is the service it depends on, which is a customer hyphen service. After that we need to mention the environment as well, and for that we can mention like customer hyphen service hyphen URL, and what is the URL for this one, which is HTTP, and here we can say customer hyphen service, and what is the port number, 8085. That's it about our services, all the 3 different services. Apart from these we need to add volumes at the out of the services level, like these are the volumes, and we have customer hyphen data. Next we have order hyphen data. Next we have rating hyphen data. These are 3 volumes we are going to create. Next, apart from that, we are going to mention networks which are out of the services, and here is the backend. That's it, we can save it. So with this we are done with our Docker file. So let us cross check what all things we have mentioned inside Docker. First thing, we have mentioned the services. First is a customer service. For that we have mentioned the build, contest, container name, ports, volumes and networks. Similar way, we have mentioned order service. Now for order service, we have mentioned depends on, because order service depends on customer service. So we have mentioned these two entries, order service and environment, and this is the customer service URL. Order service will refer. Now this is the rating service, and finally we have added volumes, and these are the networks. These are the volumes which we have mentioned, like here. This is the volume, and we have mentioned it here. And finally, these are the networks. We can save it. Now we have successfully created Docker compose file. Now let us run it. If you are not able to see it as a full view, so anyway, I am going to add the code link into the video description, so you can follow and download the Docker compose if need be. Now let us go to open the command prompt, and we can run the command. Now first of all, we can check like whether any container is running. There is no container, images and volumes. Seems good. So for this, like, you need to open the Docker desktop. So this is our Docker desktop. Next, you need to open the Docker Hub, because what all images, if there is a dependency of any image, we can pull or download the image. For example, in case of MySQL and PostgreSQL database, we need to pull the images or download the images from the Docker Hub, and then we can run the application container. But in case of H2, there is no need of pulling or downloading the H2 database image, because it is inside the Java process that H2 database is running. H2 database is a file-based in-memory database. Now this is the Docker Hub, and this is the Docker desktop. Now let us open the command prompt, and we need to open the command prompt. This is the Docker compose, which is out of all the three services, we have kept it at the root level of the parent folder. Now we can run the command. What is the command? Which is a docker compose, and we can use up -build. This is the build command. It will create all the images and container for us. We don't need to run different commands for build and running the containers for different services. Now let me check. Yes, you can see this is the Docker compose container. Inside that we have these three different containers running, and we can see it has created the images for us as well and builds as well. Okay, now let us test our application by hitting the post one. First of all, we can go to our customers, and let me copy this part. Here is a get command. Let us check. Now we do not have any data, as we are using the H2 database. We need to add it again. Now let me post it into the customer. So this is the first record. Let me add one more record, like it's a Kiran, and this is the Kiran, and it's Kiran is from Bangalore location. Let us add. We have two records. We have added successfully. Now let us test it by hitting the get command. Now we have two records. Seems good. Two customers, customer ID 1 and customer ID 2. Now let us test our orders by calling the get method. So it should show empty, because we have not created any order for the customer. Now let me add endpoint, which is a create order, and this is the request body, and this is for customer ID 1. Okay, name, price and quantity. Now let me use the post HTTP method, because we are going to create a new order. Inside this, it is giving a call to the customer service from the order service, and then if the customer is existed, in that case it is going to create the order. Seems good. We can see it has created one order for customer ID 1. Now we have two customer IDs 1 and 2. So let us add one more customer ID and check, like this is for HP. Now we can add for ASUS, and price we can give something like 47,700. Quantity we can make it 3, and customer ID we can keep 2, and let us check. Seems good. Now we have two different orders. If we call the get method by using the get API, so it will show two different orders. With this, like now, the one more thing we need to understand, like we are not running all these services, microservices from the HTS editor. Rather, our containers are running using the Docker Compose, and with these containers we are testing into the Postman, and it is giving the expected data result, like by calling the endpoint within the order microservice as well as within the customer microservice. Now let me hit our rating service. So this is the ratings, and check what it will show. We have 3 different services running. This is the get method. Ratings, let us check what is the endpoint we have used for rating. So this is the rating, not S. S is not there. So let us hit now. Seems good. Now it is showing product has overall rating 4, which is the best among the ratings, and this is the message it is showing. That means our service is hit, and it is showing the endpoint result as expected as a response. With this, we have understood what is Docker Compose and how we can use that to create multiple images and create multiple run the multiple containers out of that images. Now we can see with Docker Compose we have created multiple containers for all the microservices, and here these are the images we have created for the 3 different microservices. Now this is the command with which we can build our microservices containers for each microservice. With this command it will create containers for all the microservices. If we want to stop the microservices container, then we can use this command, and if we want to remove the running container instance, we can use this command, like which is docker compose down. Similar way, if you want to remove and rebuild cleanly, so this is the command which will remove volumes and orphans. So and after that we can rebuild it again. If we want to restart all the services or all the containers, we can use this command, and if we want to restart a particular container, we can use this command. So these are some important commands we can use to start the container and stop the container and remove the container, and we can rebuild it and restart it by using all these commands. Now let us try with our stop and down command, and I will show you how it will stop all the services and how it will remove the instances by using the docker compose down command. Now let me use docker compose stop command to stop all the services, and if you want to remove the instances, so we can use this down command, and we can check now inside the container there is no container running because we have used this down command. With this docker compose down, it will remove all the running instances of the container. So this is how we can make the efficient use of the docker compose. Like we can create this docker compose file in which we are going to mention everything inside that. These are the different microservices we can mention. Per microservice we can mention what are the ports, port mapping, volumes, and networks, and if there is any dependency for any service, we can mention the depends on and environment. This way we can create one docker compose for multiple microservices. And even if like we have considered 3 different microservices for now, but if you want to add a service discovery microservice or API gateway service, for all the microservices you can define all the microservices inside a docker compose and in one go we can run the command like docker compose up build or like down commands to remove the container instances. So this way, like we have understood the importance of the docker compose. Like with the docker compose we can manage the multiple containers for different microservices, and with single command we can create the image and start the container for all the microservices, and it will take care of everything like big network, ports and volumes and depends and environment, or everything will be taken care by the Docker Compose. And even we do not need to worry about the sequence and order of the all the containers, like how it is going to create. It will take care by the Docker Compose. Now one more question that comes in our mind, like if we are using the Docker Compose which are out of all the microservices, and inside that we are adding all the stuff for all the microservices, then why do we need this Docker file for each and every microservice? So basically Docker Compose will not will refer this file. If we check the Docker Compose, like this is the Docker Compose for this customer, it is the build and context. For this context, it will refer the Docker file, and inside Docker file we have mentioned how it is going to create the container. This is the container definition. So our Docker Compose will refer this refer the Docker file which is inside this context. Okay, and accordingly it will create the containers. And moreover, like if in case like let's say with the help of Docker Compose, if we are working with 20 plus or 30 plus microservices, and if we have any problem and if we want to cross check the result for a particular microservice for a particular endpoint, then running the Docker Compose and starting all the different 30-40 microservice is not feasible one. Rather what we can do, like we can create one Docker image for a particular service and run that service into the container and test the result, and if we find any resolution or fix for the issue, then we can fix it and rebuild the image and run the container for that application and test it. So with this, like we can utilize the resources and for the container as well as for the service specific, like and the main important thing, like with the help of Docker Compose, in one place we can define everything for all the microservices, so that we can run it with a single command, all the containers for all the microservices. From one place we can control all the containers, and it will have everything like what all services, service dependency, its port number mapping, and like there is any volumes and networks. All these things will be taken care by the Docker Compose. I hope you must have enjoyed this, and I will request you all, please do not forget to like, subscribe and share, because I need your support to grow my channel. Thank you so much for watching this.